I'm Carl Strathearn. I'm going to be introducing this talk on behalf of myself and Dimitri Garcia. We'll talk about the Task2Dial, a novel task and data set for Commonsense enhanced task-based dialogue grounded in documents. So our task description, we want to create a data set for real-world use. And in our example, we use a cooking scenario. And we want to be able to embed within this data set certain common sense values. And one of the areas we're looking at is the ability to swap objects for appropriate alternatives. So in our cooking scenario, the user may not have all the necessary ingredients to complete a recipe, but they may have appropriate alternatives in their kitchen. And we need to be able to direct the user to be able to swap those ingredients and continue on the task. Secondly, we want to consider how the user may ask additional questions on that task, things like the utility of objects, object explanations, what objects may look like, and also if an object is missing, is not present within a scene, the common storage location of that object so the user can locate it. For our proposed task, we use something called the information giver, information follower format, where the information giver has access to the recipe and the information follower does the practical task and follows the instruction of the information giver. Within our data set, we propose 4 challenges. So the first one is how we can capture natural human-human conversations to move away from the formal language typically used in instructional documents to make it more clear to the user. And generating from this set requires paraphrasing, as instructional responses might have been modified from the underlying document. So we take an original recipe and we adapt it using our method. Common sense knowledge is required since questions might not necessarily be grounded in the document. So we have to think of new ways of structuring our data set, creating additional data sets from our original data set as well. And generating requires planning based on context. So we need to be able to follow the sequence of a recipe, go out of that sequence to be able to answer questions, and then go back to the correct stage within that given sequence. So our motivation and aims. So existing models and data sets such as the multi-WAS, Taskmaster1, Task2Dial, and the action-based conversations data set, these are all data sets used in virtual models for things like online booking and reservation systems. And the issue with that is they are highly structured, and highly structured data sets like that are not very useful in real world scenarios because the real world is highly variable. So in the Task2Dial data set, we consider a practical real world scenario. So the data set has to be adaptable. We need to include additional information so the user can ask questions so they gain a greater understanding of the components and tasks of steps of a task, to be able to ask for clarification and to be able to model it on natural conversation to enhance understanding and towards task success. And additionally, one of the other things we found was that in most instructional documents and data sets, there tends to be components missing. So for example, in a cooking recipe, they may say, take the hot pan out of the oven. Well, we want to make this accessible and not presume the user has ever cooked this recipe before or cooked before. So we would say something like, using oven gloves, take the hot pan out of the oven. So what we did is we did 3 experiments for our pilot study. In the first one, we had the information giver and provide the information follower the steps of a recipe over the phone, and the information follower provided responses to that, and then we transcribed the results. Then we did a similar experiment using just text-based dialogue. So we had Google Documents, and one person took the role of the information giver and provided each stage of the recipe, and the information follower provided the response. And in the final study, we had one member of the team who did both roles, the information giver and the information follower, which is a self-talk approach. And from these experiments, we found that all the results were pretty similar. However, it was more time-consuming and costly to have 2 people working on one set of dialogues. So that's why we elected to use the self-talk approach. So for our data source and selection process, we picked open source and Creative Commons licensed cookie websites, and that's to avoid the red tape of copyright. But also it allowed us to look at feedback that was given by people who had already cooked these recipes, so we could ensure that these were high quality recipes. So we created a dataset template. So if you look on the left-hand side, you'll see the original recipe. And what we wanted to do is to format this, break it down further from kind of a block of text into the information giver follower format. We wanted to focus on common cooking utensils and ingredients that we want to extract from the data set and create additional data sets using them. We want the user to be able to provide full responses, long responses, which we are modeling for domain specific intents, and also common responses, things like yes, okay, next, which are global responses that can be used for other domains. And we also want to recompose the original text to focus on the practicalities of cooking scenarios. So that's similar to what I mentioned before about, using oven gloves, or maybe in a recipe it says, I don't know, spread butter on toast, but it doesn't say using a butter knife. So we want to increase accessibility that way. And through this, we aim to capture two types of knowledge. Firstly, document level procedural context. So that is what is the next step in the recipe. And also common sense, which is answering questions that are not available in the document, and how we can structure our data set to be able to accommodate that. So our data collection methodology, we had a team of research assistants from the School of Computing who were employed on temporary contracts. They completed a trial, and after the trial they were given advice on the best ways to format and structure the data to ensure high quality. They were also given a shared workspace with online folders, and there was an administrator on hand during regular working hours to provide support. So we did this as an alternative approach to crowdsourcing. So the annotators were given equal workloads, which were adjusted accordingly over time per their ability. The data collection was scheduled over 4 weeks. This was to permit the research assistants additional time for study and work outside the project. They paid an hourly wage at the university's student worker rate. They were given the option to work flexibly in their spare time and not commit to a specific work pattern or schedule. They were provided weekly updates with targets, and they were also given regular support by an administrator. And they also had a shared forum to be able to discuss issues and ideas with each other. And the outcome of this approach is we had incredibly high quality data, and we did not discard any data either, which was an issue in a very similar data set to ours, which is the Task2Dial Dataset, where they had to get rid of a lot of their low quality data. So this example of one of our recipes, at the top we have the title and the original hyperlink to the original recipe. And from that block of text, we look at our metadata, which is our ingredients, our servings, our times. And we format it in this information giver, information follower format. So the user is the information follower. The robot in this instance is the information giver. You can see the underlined text is our utensils. And from that, we create a data set. And also from the metadata, the ingredients at the top, we created another data set from that, which I'll explain later. And the other thing we did is, if you look at the user responses, we have domain specific responses, which is something like, okay, I have added the ingredients to a mixing bowl. And then we have our global intents, which is, what do I do next, which can be used in any domain, not cooking. It could be used in things like furniture, assembly, or maintenance tasks. So we analysed our data set and we compared it against the Task2Dial data set, and you can see that Task2Dial has a high number of documents than we do, but they're spread across 4 domains. We are single domain. We have a high number of turns and tokens per turns, and we are more lexically rich. And the majority of both trigrams and bigrams are only used once in our data set, which is 75% and 59% compared to Task2Dial's, which is 54% of bigrams and 70% of trigrams that are only used once. So I want to give a quick overview of how the dataset can be used with an API, and this example is with Rasa. So from our original cooking dataset, which you can see on the left column, we have our recipe steps, which were turned into utterances for the user to be able to follow the instructions. The user is able to provide long or short responses. So the long responses are our domain-specific intents, and our short responses are our global intents, and they were modeled on the human responses from the original dataset. And we also allow the user to ask questions, which were modeled as actions within the language model. So the user can ask for alternative ingredients, utensils, and then return to the appropriate step within the recipe. This is a quick example of what that looks like within the model. So for example, if the user was asked what a bowl is, we can say a cooking container that is usually larger than a cup and kept in a kitchen cupboard is typically made of glass, ceramic, or plastic. So it's what there we have a description of the object, we have a comparison of the object with something similar, we have its common storage location in order to enhance the user's ability to understand and find that object. With other objects as well and utensils, things like knives, we also offer correct handling of the knife. So we might say hold by the handle and cut away from the body. So for our alternative ingredients, one of the important things within this is we wanted to use ingredients that we could swap but did not change the whole structure of the recipe. So if you were to swap something like chicken for fish, that would change everything within that recipe, how that was prepared, how it's handled. There'd be significant changes to the recipe itself. But it's what we want to do is we want to be able to easily swap out ingredients that do not change the structure of the recipe. So example, swapping plain flour for bread flour or oat flour. That's a straightforward swap, and you do not need to change the structure, and it does not affect the outcome of the recipe. And here's just a couple of example dialogues from that. So on the left-hand side, we can see the common sense use of correct handling. So to move a hot chicken from a pan, use a fork and tongs, or to move something from an oven, use oven gloves. On the right-hand side is what we have is the ability to swap ingredients. So things like I don't have any butter. Instead, you can use olive oil, ghee, Greek yogurt, etc. So in conclusion, we introduced Task2Dial Dataset modeled on everyday conversations between an information giver and information follower during a cooking task. We extend previous work in document-grounded dialogue systems to emulate the unpredictability of human-human conversations. We did not follow a tight sequential structure as in previous models. We proposed a new task-associated dataset and demonstrated how Task2Dial can be used with an API. Our proposed task aims to motivate research for modern dialogue systems that address the following challenges. 1. Modern dialogue systems should be flexible and allow for off-script scenarios in order to emulate real-world phenomena. And 2. As dialogue systems find different domain applications, the complexity of the dialogues might increase in structured or unstructured ways in documents or databases, etc. So for our future work, we want to benchmark and evaluate our dialogue system and in what we call the ChefBot model, which is our API. We want to extend this approach into a practical human-robot interaction HRI cooking scenario. So we actually use the dataset and a model within a real cooking scenario. And then we want to also identify how this can be used in different domains, such as assembly and maintenance tasks. So that's our references and acknowledgements. The dataset is available on Hugging Face and GitHub with examples of how to use this with an API as well. So thank you, and if there are any questions, I'm happy to answer them.